All right. Let's take a look at these. I kind of did a little bit of rearranging on our bell work once I graded the skills checks. So I'll pass those back closer to the end today. So you'll have them so you can look at stuff so we can maybe, get what we need over break. Maybe get stuff a little locked in. I say, some of us need to really focus on this bit. A lot of us missed pieces of the VPA log BAP situation. So, I take a picture of this kid. You can take a picture of the schedule, that's fine. Walk closer to it. Get out, man. Alright, so BPA log base B of A equals B. B to the P equals A. Base is the base. So the base of the exponential is the base of the log. The power of the exponential, P, is what the log equals. It's the whole point of logs existing. So if we wanted to write 3 to the 4th equals 81 in log form, how would we do so? We're going to start with a log. What's the base? 3. Base is here. Base is here. We put it down there. Small, low. Log base 3. Of what? 81. That's this bit, because I want that bit. So our argument is 81, and that's going to equal 4. The power. That guy. So it's going to equal 4. The base of the exponential becomes the base of the log. That is part of the reason they are linked together. They are tied. That is what they do. It's what they live for. I am not going to burst into the Ursula song, but I am very strongly tempted. Poor darling souls. I could not. That's what they do. It's what they live for.
So you haven't put them in this category yet?
They should be in. I put them into Canvas yesterday, which means they should have auto-populated. All right, so let's do this one. How do we write this guy in exponential form? Our base is 2. Same pieces. I want to start with that base. So you're not bad. What's our power? 5. So 2 to the 5th equals the argument 32. I know we're gonna go home. We're gonna do things. And I'm horribly cruel. You made us math at school. Ah! I weep for you. It's the day before my break too, and you know what I get to take home? Stuff to grade. Yeah. You know what also is your job? This.
Other careers like spring break.
No. No. For the therapist doesn't expect me to work from 7 a.m. to 7 p.m. grading stuff and planning what I do. So I do. What's up?
Maybe office job.
They don't expect you to work as much as we do here.
No.
No. They also only pay us for the 180 days we're here. So it's not like we get paid over summer. So our contract is 182 days. There are 182 days in the school year. So, I mean, we're paid for the days we're here, which is valid. But like that just means it's easier to argue with people. They're like, you get paid for your summer breaks, and I don't. I don't. Nope. a lot of us choose to have our paycheck cut up into 26 paychecks instead of 22
Also,
paychecks.
you can get paid.
So I still get paychecks through the summer, but it's just that they're not paying me everything each month. Yeah. So then I don't have to be responsible for saving up for 2 months of no payment. All right, let's do the bottom one. We're doing a solve on this piece. Oh, snap, what? If I want to solve this and I have logs on only one side, this is kind of what we did yesterday. What do we do if there's logs on only one side? Give us a clue. It's very similar to what we just did up here.
You can put it in exponential.
Yeah, we're currently in a log form, and I'd really like this to not be in a log. That'd be great. So let's switch this to exponential form. So what's our base? 2. What's our power?
3.
3.
You said P.
P, power. And that's going to equal the argument, that x minus 1. So we spend a lot of time on this switching stuff because it is an important piece. We can simplify this to be able to get it to solve in a way that makes sense. What is 2 to the 3rd? Two times 2 times 2. 8 equals x minus 1. So what does x equal? How do we get there?
Plus 1.
Plus.
Add 1 to both sides, so therefore 8 plus 1.
I thought the same thing.
I know, I have long advocated for first period being the worst possible time for a math class.
I'm already talking.
The 7:15 is too dang on early. 7:15 is too dang early. It just is. I agree. I get literally no say in it.
Couldn't you have this as your prep?
Huh?
Don't you get a say in what?
No.
Your prep.
And also, I have 5th period. Take my 5th period at your own peril.
Longest period. Right?
Uh-huh.
Anyone.
And that's because I teach 3 different classes. Yes. Yeah, I have 3 classes, and most math teachers only have 2. So I get the longer prep period. That is the benefit of that. Because then also during finals, I get my prep period every day. And most teachers don't. So, benefits to it, but that does also mean we get a first period, which I feel should always be an elective math, like a pre-cal or something like that. It's a lot. Okay, questions on bell work. Turn it in today, because, like, don't try and keep track of this over spring break. So, like, we're going to try and remember to turn this in today. I want us to do a little bit of solving stuff. Not tons. Oh my gosh, I'm the worst. Let's see, is this the one I wanted? Okay, we're going to be on page 9 in your packet. Hang on. And I want to do number 7, and then we'll do the one that I wanted next, which was number 2. So I want to see number 7 up at the top. That's our ln 3x minus 1 equals 2. So this is, again, page 9 at the top in the notes. I know, I'm horrifyingly cruel. I weep. Page 9, blocking. What's up? Yep, we're gonna be solving this. My goal is for us to do 7, 2, and 1. That's the goal. So we're gonna try and do 3 of them in that order. So with 7, I have logs on only one side, so we're gonna approach it very much the way we just did the one in the bell work. Only problem is I don't see a base. What is our base here? E. This is the same thing. If I write ln, that is the exact same thing as if I write log base e of that 3x minus 1. That is the exact same thing. This sometimes helps if we're trying to figure out what our base is, because ln has a base of e. So if we were to switch this around into exponential form, we're going to have e that has a power of 2 that's going to equal our argument, this guy, 3x minus 1. Is e a nice pretty number, or is e super duper gross and decimally? Super gross and decimally. So we are going to leave it as an e as long as physically possible. So I'm going to keep this as an e squared for right now. Not get my decimal. Me a decimal. I'm good at words. So what can I do to get the x by itself? Add 1 to both sides. So I can write this left side as e squared plus 1 equals 3x. Okay. What do we do to get the x by itself now? By 3. So I divide this side by 3. So we get that our x equals this hot mess, e squared plus 1 all over 3. This is what we call our exact answer, or our most precise answer, which is great, but I have no flippin' clue where that is if I was trying to estimate or give myself a spot on a number line. I don't know. So what we can do from here is, if we need a decimal answer, we type the sucker in a calculator. E squared plus 1 over 3. It's coming. There we go. On the yellow calculators, I'm going to start by going with my fraction. To get e, we get our second, and then we hit the natural log, that ln. It even pops this already up into the exponent up here. So we get our e squared plus 1.
6.7. If you round it. Or
Is it?
6.7. Yeah, 6.7.
You have your plus 1 in the exponent.
Oh no.
Okay, so be really, really careful when you put in your e squared that you then hit the right arrow to get out of the exponent. Your plus 1 should be on the same level as the e, not on the same level as the 2. We don't want e to the third, we want e to the 2 plus 1. So we should get 2.796 blah, 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 2.8-ish. So our approximate decimal answer here, yep, so x approximately equals, that's what the squiggly equal sign is, 2.8. Okay, so when we have e's or ln, things get a little bit decimally in the answers, but keep it as e as long as we can, because we don't want to have to deal with decimals and dividing them. Gross. Okay. So let's look at number 2 real quick. Then we'll do 1, then we'll be done. Looking at number 2. Same page, it's still on page 9, it's just in the boxes down there. We've got ln of 6 plus ln of x plus 7 equals ln of 58. What can I do here? A lot. Not wrong. More specific.
Not as much.
I see logs on both sides, which means we're going to try and make it so we have only one log on each side so that I can just ignore the log part. So, is there any way that I can make those two things smush together? Can I make these smaller? Maybe can I condense? Yes. We're going to condense that left side. So that means our addition turns into what? Multiplication. Oh, wait, those things come into play. So this means I'm going to take this argument and multiply them together. This becomes ln Sorry, I try and do it where it's separate because I know cursive's not a thing we do anymore. 6 times x plus 7. That's our condensed piece here, and then it's going to equal our ln of 58. Now what we have is logs on both sides. Well, we worked with something like this yesterday. It was logs with different bases, because yesterday we did log base 15 and log base 4, that we did numbers 1 and 2 on the previous page. So if I have logs on both sides that have the same base, because these are both ln, what do? If I have logs on both sides that are exactly the same and have the exact same base. Set our arguments equal. That's exactly right. I get to ignore the log part. If we have logs on both sides, I get to ignore the log part. It's just like if I had times 2 on both sides or divide by 3 on both sides. I don't need it. So we're going to have our 6 times x plus 7 equals 58. What can I do from here? Distribute. Absolutely valid. That's going to give me 6x plus 6 times 7, which is 42. Does yours have a plus on it? Mine has a minus apparently in the equation. Love it. Okay. I'm going to switch this so it matches y'all's. I didn't even notice that. Yours is a minus. Boom. Changing it. At this point, it hasn't changed anything. Boop. Boop. I'm just writing out my pluses, making them be minuses. Boop. Okay. There we go. All right. There we go. Okay, cool. Saving that for later. Now what can I do? Add 42 to both sides. Because we want to get our x by itself. So if we, wrong pen, add 42, we get that our 6x equals what? 100. So what does x equal? Yeah, I was going to say, it's going to be decimally or fractiony, because what we get is 100 over 6, which if you type that in the calculator will simplify to be 50 over 3, or is about 16 point, is it 0.6 or 16.3 repeating? 16.6 repeating.
7.
So we get an answer. So just because it's ln doesn't mean it's going to wind up with e answers that are weird and gross and decimally. Sometimes we get number answers. We do still need to check with that. If our x is 16.6, are we going to get real answers? Or is our argument going to be positive, or is our argument going to be negative? If we have 16.6 that goes in right here.
Positive.
Positive. So this answer checks out. We don't have to do any work to show that. Just making sure that we check. If we have that as an argument, is it positive or is it negative? Okay? Let's look at number 1. Similar vibe. Kinda. Finally gonna see why I've been making you do that thing. Yes. But you know what? I'll have this be our last one for today. Okay. We'll do this one as the last one, but this is going to show us why.
Are we going to do 3 and 4 after break?
Probably, but honestly, I haven't detailedly gotten out of it.
Okay. So are we not coming back to 8 then?
Oh my god. I'm so tired.
Top page, next 7.
What?
I'm just going to stop.
Okay. My brain's not processing, especially because Caden's out there making faces at me in the hallway.
Oh my god.
Mm-hmm. Giggling like he thought I couldn't see him. All right, so number 1's very, very similar. What are we going to do first? condense. I have a plus right here. That means I need to multiply this argument times this argument. So this is going to become our ln, and those two pieces give us our x plus 3 times x equals our ln of 54. So we condense it together. Then what can we do? We can get rid of our ln's. We've got ln's on both sides, and there was only one of them. We can only get rid of them like this if we have only one log on each side, and we're left with our x plus 3 times x equals 54. What can I do with that? Distribute, yeah. Let's multiply this piece out. That's going to give us x times x squared gives us x squared plus our 3x equals 54. How do we go about solving something that has an x squared in it?
Greatest common factor.
If we had a greatest common factor, yeah, we could do that. Can't square root it because we don't have perfect squares here. This guy's not square rootable. Good instinct though.
So we do this.
We want to get all the way down to an x equals. Oh dang. I'm gonna give us a little clue right here. What do we use those for?
Xbox.
To do what?
Factor.
Factor it.
That's what I meant, because my brain goes to greatest common factor, and that's what I see.
Awesome. It is a part of it, but it's just one of those things I'm like, not quite. So what do we need to have this equal before I can factor it? 0. So we have to set this thing equal to 0 first. So this is going to be our x squared plus 3x minus 54 equals 0, because I have to subtract 54 from both sides. So we need it to equal 0 first. When we're factoring, wow, I had this way over to the side. Scooching this over. What are we going to put up here? This is our a times c. And b goes on the bottom. So what's going to go up here? Negative 54. What's our b? What's going to go on the bottom? 3. So what pair of numbers will multiply to make negative 54 and add to make a positive 3?
Hold on.
Think about things we know that multiply to make 54.
Negative 6 and positive 9.
Negative 6 and positive 9. So that gives us the two middle pieces here. We take our x squared from our equation in here. We have our minus 54 from our equation. And we use those two pieces we just found to fill in the box. You do not, again, have to use box method for factoring, but it is a familiar for a lot of us. So do the factoring part. Get to our roots. We want to get to those solutions. I want to know the x equals bit. So do the factoring. Pull our factors. what do we get as our factors here? Oh, I've got the backer. When we pull our factors in columns and rows, what do we get?
X 9.
Mm-hmm.
X -6.
Yes. So our factored form here is going to be that x plus 9, x minus 6 equals 0. So what are our roots? Those solutions, zeros, x-intercepts, those guys. What's our x equals? How do we get to those solutions? Yeah, because we're taking the, so it's like setting those pieces equal to 0. The x plus 9 equals 0, x minus 6 equals 0. So we get the opposite sign of those values. So we have x equals -9 and x equals 6. Ooh, there we go. So now we need to check them. If I take my x of 6 and I substitute it into the x's up here, are my arguments going to be positive or negative? 6 plus 3 and 6. Are those positive or negative? Positive. So 6 definitely works on the check. What happens if I do the check with our -9?
No, it's gonna be
We would have negative arguments. That's the whole thing we've been checking for. We can't have negative arguments. So this -9 is not a valid solution. So this guy does not check. The official term for that is extraneous. Oh my gosh, the man is doing so much work and it's not even an answer. That's so extra. Oh my god. Oh my god, that's so extra. Okay, I was gonna say after the break, you should be done with that. It's 10 minutes still, dude. Oh no, it's not, it's 5 minutes. Okay, so that one is extraneous. That means this is not actually a solution. We did all this work and this -9 doesn't count. But the 6 does. The 6 is our answer. So sometimes even when we get 2 answers, only one of them works. We can also have it happen where none of them work. Okay, so it's important that we check. All right, so I'm gonna begin crafting these out. Please make sure you remember to turn in your bell work. Please don't try to craft it over break. We have about 4 minutes left in our argumentatively short period. Homework 3 is not due until after break anyway. Due on the Tuesday. If you need a copy of the schedule, they're on the all 3 boards around the room.